Okay, so this slide is, to say the least, a bit tough to comprehend, so I'll do my best. In 1986, Bliss and Lomo, two scientists, were the first to confirm the Hebbian synapse, and they did it via this mechanism, the hippocampal slice technique, where they put electrodes in the stimulating pathway called the Mossy fibers, and they recorded cells in an area of the hippocampus called the CA1 area. Okay, so what they did is they stuck the electrodes in and they measured a response. They give a certain pulse, say 5 millivolts pulse, and they measured a response. So this triangle here represents what's called the slope of the EPSP. Remember the EPSP, right? It's the first inclination of the action potential. It's where it first rises. That's the threshold phase of the action potential. It's technically a combination of EPSPs. So what we're measuring is the slope, whether it's slow or it's steep. Got it? So a slower slope would be less efficient than a faster slope. This would be a faster slope. This would be a slower slope. So we start by just measuring baseline recordings. So you stick an electrode in, you give the same pulse, you measure the slope. It's consistent, 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 consistent. Now we have an established baseline of slope. Then you give what's called a tetanus, or a high frequency train to stimulate repeated stimulation as you would see in the Hebbian synapse. And then you give the same 5 millivolt pulse and you get what's called a potentiated response. This is evidence that the synapse is now more efficient. The same stimulus creates a more steep slope and a quicker transition to an action potential. Okay? So this is what we call long-term potentiation. When this happens with a high-frequency chain, as you can see, this potentiation can last for minutes. It can last for hours. It's been shown to last for days. And so when this was first identified, people got the idea that this is the cellular representation of learning. So the similarity is this: you sit in class, you learn some information, but then you go home and you study. You repeat, 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 repeat. That's the tetanus. That's the high frequency train. Okay? And so when you come in to take the test, now you have learned. And if we ask the question on the test, you're able to put the proper answer down. Where over here you could not do it. You couldn't do it until repetition occurred. So long-term potentiation, or LTP, is considered the cellular property of learning.